The force with which Earth attracts a body towards its center is the weight of that body. I told you this previously. If weight is force, then force is expressed in terms of mass and acceleration. So we can define weight again in terms of measurement by this way. Weight of a body is the product of its mass and acceleration due to gravity. W equal to mg. This way, weight is the product of mass and acceleration due to gravity. After this much understanding, now I want to tell you that the weight of a body varies from place to place of the earth. Now let's talk about the variation of weight of a body in different parts. Now I want to take some facts and in the light of some of the previously understood materials, we'll verify this fact related with weight, that is variation of weight. Look at this. Number one, weight of a body is more at pole than the equator. This is let's say Earth, and Earth is flattened at the pole and bulged at the equator. That's why polar radius is less, equatorial radius is more. The question, or we can say the fact, is weight of a body is more at this place. This is North Pole. Weight of a body is more at this place. This is South Pole. Why weight is more at this place? A body is if taken here. Why weight is more? Now let's talk about the previous understanding. What I told you in previous class, acceleration due to gravity is inversely proportional to square of the radius of the earth. The meaning, if radius is less, g will be more. So at this place, I mean to say at pole, the radius of the earth is less. That's why g is more. Where it is more? At pole. G is more. And weight of a body is the product of mass and g. Mass remains same. G is more. That's why product of mass and g will be more at pole. But radius at the equator is more. So here g is less. If g is less, then the product of mass and g will be less at this place. So weight of the same body will be more at pole, less at equator. Now let's talk about second. Weight of a body is less at the top of the mountain than the bottom. Let's say there is mountain and radius of the earth at the top of the mountain is more, but at the bottom of the mountain radius is less. Since radius is more at the top, that's why g will be less. And here at the bottom g will be more. If radius is more at this place, g is less, and the product of mass and g, that is weight, will also be less at the top of the mountain. Let's talk about third fact. Weight of a body is more at sea level than any other place. Now let's talk about this. Sea level is in the place where radius of the earth is very less. At sea level, radius of the earth is very less. If radius is less, g will be more because g is inversely proportional to square of the radius of the earth. If g is more, then the product of mass and g, that is the weight of the body, will also be more. That's why weight of a body is more at sea level than any other part of the earth. Let's go to fourth fact. Weight of a body is different in different parts of the earth. Now again, look at this diagram. Somewhere radius is less, somewhere radius is very high, somewhere not so high, not so less. Radius of the earth is different in different parts. And as we know, g is inversely proportional to the square of the radius of the earth. That's why g varies from place to place of the earth. And if g varies from place to place, then the product of mass and g, that is weight, also varies from place to place of the earth. So weight of a body is different in different parts of the earth. Let's talk about another point. Number 5. Weight of a body decreases as we go up from Earth's surface. Now let's come back here. If we are here on the surface of the earth, if we go up somewhere here with this body, then weight of the body will be less at this place but more at this place. What is the reason? Now I want to recall the gravitation. When I defined gravitation, it was defined like this: the gravitational force between two bodies is inversely proportional to square of the distance between their centers. It means at this place the gravitational force between this earth and the body will be less, because if distance increases, gravitational force decreases. Since gravitational force of the earth acting on the body is the weight of this body, that's why weight at this place is less than that of the surface. Now let's talk about another point. Number 6. Weight of a body is more on the earth than the moon. Earth's mass is used in comparison of moon's mass. It is about 6 times greater than moon's mass. That's why the attraction force of moon on a body lying on its surface will be less than the attraction force of the earth on the body lying on its surface. Because this attraction force of earth, which we say gravity or gravitational force of the earth, or attraction force of the moon, which we say gravity or gravitational force of the moon, the gravitational force between two bodies is directly proportional to the product of their masses according to Newton's law of gravitation. Since product of the mass of earth and the body and is if compared with product of the mass of the earth and the body is if compared with the product of the mass of moon and the body, then the product of the mass of the earth and the body will be more than the moon. That's why a body weighs more on the surface of the earth than that of the moon.